Welcome to another video of Math Magic with Jen. Today we're going to look at integers. It is a topic in 6th grade. And yes, the focus will be on number lines. So first off, what is an integer? An integer refers to all positive whole numbers, their negatives, and zero. Sometimes they're also referred to as signed numbers in the Common Core textbook. So either signed numbers or integers. Okay. So one of the first things that gets introduced when students are learning integers is a number line. They actually use both horizontal and vertical number lines. Couple things to remember, and that is that we typically put 0 in the middle, although you don't technically have to. You do want to use the same scale as you go from left to right. So are we writing it every 1, every 2, every 3, and that sort of thing. As you can see, positive numbers are to the right, so this way is positive. Negative numbers are to the left. And you can see a nice mirror image here that I have 1, 2, 3, and on this side I have -1, -2, -3. So again, you probably as an adult are used to playing with number lines, but 6th graders with negatives may not be that aware. Who knows? Just make sure you are going over it with your students. I briefly mentioned just a minute ago about scale. So what is scale? So scale refers to what each tick mark on the number line represents. So are we doing it every 1? So sometimes that's the best way to do it, depending on what numbers you're going to graph. Sometimes we want to do it every 2. You could even do it every 5, every 3, 4, 7, 12, whatever you want to do. Typically, I'll look at trying to do every 2 or 3, depending on the problem. So here it says, draw a number line and create a scale for the number line in order to plot the points -2, 4, and 6. Now, this is a great discussion point because counting by 5s is probably a bad idea because you'd be kind of guesstimating where 2 and 4 and 6 are. Whereas if I were to use every 1 or every 2, this would probably be a great job. So I'm going to start this one because maybe that one would be the best one to plot. And by the way, plotting points is just drawing a dot, a filled in circle. Sometimes the Common Core textbook will have us name them, like plot -2, call it A. So that's just kind of following directions and practicing. Okay, let's talk about opposites. What is the opposite of a number? Okay, so Common Core actually does a really nice job of having students kind of guess what an opposite is and then try to define it kind of after the fact. So here it says plot the points -2 and 6 as well as their opposites. So we'll start with -2. And we would have our students talk about what they think the opposite would be, and they're probably going to guess +2. So -2 and +2 are opposites. And again, 6 and -6 are going to be opposites. Okay, so for them to kind of verbalize or write down, talk out how they figure this out, a couple things that they could talk about. Opposites are the same distance from 0. So yeah, -2 is 2 away from 0, and +2 is 2 away from 0. Well, probably the most common thing they're going to say is they have the same digits, but one is positive and the other is negative. So 6 and a -6, an 11 and a -11. Okay. You could also do some kind of symmetry here that there are mirror images from 0 on the number line. So if you can imagine a mirror here at 0, and I fold my paper at 0, then those are going to line up. So opposites would line up. So -2 and 2, -6 and 6. And again, it kind of circles back to they're the same distance from 0. Lots of good discussion points about how to talk about what they think an opposite is. Okay, here's a sample problem. The reason why I wanted to tackle the sample problem that's in the Common Core textbook is because it hits on a lot of really good stuff that seems really simple, but then kind of stops and thinks. So, or makes us stop and think. So the first thing it says is create a scale in order to graph the numbers -12 through 12 on a number line. So this could be a good discussion point. Do we want to go every one, every two, three, four, five's probably a bad idea, but we could talk about factors of 12 would probably be a good place to start. So without knowing anything, I would probably go, oops, every one, every two, three, four, six. These would all be good choices. And I put good in quotation marks because we aren't told how much detail we want to put in, so maybe it'd be better to do the smaller numbers versus the bigger. So talking about, the positives and negatives, the pros and cons about which scale to choose. Okay. Now, you can see by my picture that I chose every two. So here's my number line for every two. And then it says, so here's what we're going to walk through. Choose an integer between -5 and -10. Label it R. Okay. So we want our students to plot a point, any point that's between -5 and 10. Now we can see -10. -5 isn't technically on here, as in it's specifically listed, but it is somewhere in here. So I want them to choose anything between here. So maybe they choose the number -8, and we're going to call it. Then it says, what is the opposite of R? So again, discussing opposites. So they've already practiced that. We're going to do it again. So here the opposite of R is 8. And here I'm going to get a Q. State a positive integer greater than Q. Okay, so choose anything greater than Q, label it T. So here maybe I choose the number 12 to name it T. Then it says, okay, so here's where I'm going to kind of focus because this is the sneaky tricky, okay? State a negative integer greater than R, label it S. Okay. So this is where it gets kind of confusing because what kind of number is greater than -8? Is -6 greater than 8 or is -10 greater than 8? And we could have students discuss both ways and try and choose, but there's actually only one right answer. And here's how I like to tell students how to think about it. So typically on positive numbers, they don't have to think twice. Remember, this is sixth grade. So when we did a positive integer greater than Q, everyone knows it's going to be something that's to the right over here. So what I would tell students is that on a number line, greater is to the right. Okay. So here for positive integers, right? Greater is to the right and lesser is to the left. So numbers like 2, 4, 6, and 0 are all less. So lesser is to the left. Okay. Well, that's going to stay true even if we're on the negative side of the number line. So greater is always to the right. So here, the number, if I have R, which is -8, and it asks me to state a negative integer greater than R, I want to choose any negative integer that's to the right of -8. It can be a little to the right or a lot to the right. So let's say we decided to choose -2. So that's S. So on a number line that's horizontal with positives and negatives, greater is always to the right, lesser is always to the left. Okay. So now let's try that one more time. State a negative integer less than R. So I want something less than R, a negative integer less than R. So less than would be to the left. So any of these would be less than -8, and we're supposed to label it U. So I'm just going to randomly choose this guy. Okay. Now, super important important. There are lots of ways to answer this that are correct, right? We got to randomly choose R, and based where we chose that, then we would have the opposite. So there would be lots and lots and lots of variations. So you could have two, three students working on this problem at a table group, and they all could have slightly different answers. However, they would still have that R and Q are opposites. You'd want to choose something greater than Q or greater than R or less than R and all that kind of stuff. Okay. Last one, state an integer between R and Q, label it V. So if I find R and Q, it says state an integer between there. So anything between R and Q, you could go for 0. You could go for anything as long as it's between these two numbers. Okay. All right. Before we wrap this up, will the opposite of a positive number always, sometimes, or never be a positive number? And so again, this is getting them to kind of really think about what would happen. So let's just choose a random positive number. So any positive number. So let's say you love the number 17. Okay. Will the opposite of this always, sometimes, or never be a positive number? Well, the opposite of a positive is the same value, just negative. Remember that whole mirror images around 0? So here we would say it would never be. So the opposite of a positive would never be a positive. Okay. All right. We are almost done with this lesson, but I want to talk about vertical number lines because most of us, if you've been through, algebra at some point in your life, you've played with number lines, with integers, negatives, and positives. You may not have used vertical number lines too much. They've got great applications. So one of them could be elevation. So here, when you have elevation, 0 in the middle would end up being sea level. And then when you measure like the heights of mountains and the elevation of cities and different things, all of those are above sea level. So it would be positive. And then there are plenty of things that are below sea level, not just under the water. So there's a basin in Death Valley that is the lowest point on North America. But the whole thing is that you could have below sea level being actually under the water, or just points on Earth that are technically below this. So here's our below sea level. So you could do an activity where maybe you look up different cities around America or the world, look at their elevation, or look at the tallest mountains or the lowest points, all sorts of interesting things. Okay. You can also do this with temperatures. That being said, temperatures usually work better if you're talking about Celsius, because for Celsius, water freezes at 0. In Fahrenheit, it freezes at 32. So you're not really getting negative numbers really when you're playing with Fahrenheit. I mean, technically you can, but it's a lot better if you're playing with Celsius. So here you could have freezing and above freezing and below freezing. So that's just an idea of 2 applications that use vertical number lines, but I'm sure there's even more than that. And that's it for this video of introducing you to the concept of integers, opposites. We talked a little bit about scale and number lines, both horizontal and vertical. So a little bit of a good start, hopefully, on integers. Keep working on it. I hope it goes well. I have 2 more videos on integers. One is going to focus on application problems, and the other is going to be adding. So keep an eye out for those. Until next time, keep working hard, and good luck with your math. Bye-bye.